So this is a simulator that we've developed that simulates an apple pie production plant, and it compresses an 8-hour shift into 90 seconds and has some mayhem that happens during the course of a production run. So we're going to launch one, and Chris is going to walk you through what's going on here.
So some of you guys have seen this demo that we've done before. This one we wanted to bring into the webinar to just throw context into this. And so your standard run rate that we should be making these pies at should be 300 pies per hour. We're just showing you one oven. Normally a facility like this would have an overview of all of their ovens. But this is the viewpoint that the operator is going to see on the line. Just to point out a few quick things of everything is in real English. You don't notice the words OEE anywhere on this screen. It's asking questions like, how is production doing? And it's measuring it in terms of perfect or steady or slow, as opposed to a 77% that somebody would say, is that good or bad? Makes it really easy with the use of colors, that if it's gray and on top, we are producing correctly. These are each 12-minute intervals with a perfect number of 60 pies in that time. And anything that is underproduced is going to show up in orange under the line. So it's easy to see where my gaps are of good production. It's showing the run, which we're doing incredibly fast for you, 8 hours in just a short span. But normally it would tell you what your run end time is, how much time is left. You're able to easily see the actual produced versus the planned produced, the rate that we have been averaging, the run time, we're up to 7.5 hours right now, how much of that time we've actually been producing versus the total delay that we have incurred. So this normally helps people in scheduling to be able to know that I'm running almost 2 hours behind. We can dynamically push the rest of our scheduling out. And also management would be alerted because this has occurred too much downtime, too much delay. So that production manager is going to be looking at this screen and this oven very closely and would be probably alerted by text at this point. So Titus, do you want to show, well, let's do one more thing. The other thing that I'd like to show you is that this same run right here, we need to look at it from the real-time perspective. This would be that management screen. Now you'll start to notice that you do have full OEE here, and we're looking at a lot of good quality. Remember, these are simulated numbers, folks. The performance on this run is 86. That's our rate. But our availability, we experienced 11% loss in our downtime that attributed to, you know, not the best OEE score for this oven that we should have been occurring. And so our big delays here was that the oven was too hot. That accounted for a lot of the counted downtime, but most importantly, it accounted for 30 minutes of that. And so Titus, do you want to take over and magically fix this as our maintenance team?
Yes, I will. Let me break out my virtual wrench here.
And imagine that this is a very standard practice of the production manager would be going out to that maintenance manager, looking at this problematic area, using the continuous improvement type tools within the organization to say, this is too large of a problem. Let's fix this downtime code. So now that we have magically fixed it, we're going to start another production run with this in mind.
So I'm going to reset the production run that we just did, and I'll enter a new one here. And away we go.
So as our production run is going again, I just want to show you another couple things. Within any of the standard systems, there would be top downtime reason codes. The nice part is that this is sortable and searchable so that you could see it within any time period for any machine, for any line. You could see it with any date range. You could keyword search for one of your machines and sort it by group or by person, all in the effort to figure out what your top downtime reason codes are and what you should be focusing on. Another element that is common within a lot of these systems is the ability to see all of your production runs. And so we'll come back to this screen in just a second, but I'll give you the overview first. Each line is equal to one production run. And so it's date-coded, time-stamped, has the job or work order that you've used, and it gives you your OEE score. Any of these columns can be searched or sorted, modified by the date range, sorted by different groups. And this is the ability. The screen looks very benign, just tabular data, but it ends up being, seriously, one of my favorite screens. This is the ability for you to be able to look at it and say, over the last month, how did oven number 5 do? What was its average OE for the entire month? Show me all of those production runs. Okay, now show me team 1 versus team 2. Okay, when we were making cherry pies, how did my OE compare to when I was making apple pies? Okay, how were cherry pies across all of my machines? This is that analytics tool. And remember, this is a simulator. This is just one part of it. There's another screen that is even cooler than this, but it's not a part of this demo today. So coming back to this production run, we finished, and you notice that we had a lot less downtime within it, and our OE score has gone up. You'll notice that there were less bars underneath the line in orange. We want to come back to our real time, and we did improve our OEE overall. Our performance was down a little bit, but our availability was definitely up. If you look, we didn't have our same downtime reason codes. We were able to cut out that oven being too hot, and it was the ability to increase the performance out of that machine. And so we were able to physically get more pies off of that line within the same time frame.